Good day, learners. Welcome back to our mathematics class. Today is going to be the continuation of our circle geometry. In today's class, we are going to be looking at cyclic quadrilaterals, and this is going to be our theorem 5. Just before we venture into this properly, if you are a new member on this channel, kindly do well to subscribe to my channel and click the notification bell for my subsequent content. When you click the bell and it will bring an option, click the personalize so that you can be seeing my subsequent lessons whenever it is being released. So let us dive into properly. Now, let's look at theorem 5, which is under the cyclic quadrilateral. The word quadrilateral means four-sided figure. A four-sided figure being inscribed in a cycle. In a circle, that's what we call cyclic quadrilateral. And the angles of this quadrilateral are touching the circumference, meaning we have four angles on the circumference. Now, we now want to prove the theorem 5 that says the opposite angles of a cyclic quadrilateral are supplementary. Opposite angle that are opposite to each other. In a cyclic quadrilateral, they say the angles are supplementary. Or we say angles in opposite segments are supplementary. Don't forget, we're talking about opposite segments. We have the minor segment and the major segment. Meaning that we are going to have one angle at the minor segment and the other angle at the major segment. When you sum them up, it's going to be equal to 180 degree. Given. We are given a cyclic quadrilateral ABCD. ABCD. We want to prove that angle BAD plus angle BCD is equal to 180 degree. That is, when you add these two angles together, it must give 180 degree. We should note that the sum of supplementary angles is 180 degree. Fine. Construction. Join B and D to the center O. This is B and D. Join them to the center. This is our center O. We join B to the center O. We join D to the center O. Now, proof. Angle BOD is going to be 2y. That is, I want to calculate the angle that is here. The x is an angle on the circumference, and the center of x is this point. To get the center is going to be 2 times angle at the what? Circumference. Angle at center is equal to 2 times angle at circumference. So this place is going to be 2x. Then reflex BOD. Reflex means the other side of this BOD, which means this place, reflex BOD. Then reflex to BOD. So the reflex is opposite of this. It's going to be 2y. When the angle here is y, the center of this angle y is this other side. So this place, we have our angle here to be 2y. Now, 2x and 2y, both of them, they are angled at a point, which means that if I had 2x plus 2y, it will give me 360 degree, angles at a point. Now from here, 2x plus 2y is equal to 360 degree. What is common in both? 2 is common. 2 open bracket x plus y equals to 360 degree. Divide both sides by this 2. 2 goes into x plus y equals to 180 degree. Meaning if I sum the angle x together with angle y, it must give me what? 180 degree. Therefore, angle BAD plus angle BCD is equals to 180 degree. So this theorem can also be extended to the exterior opposite angle of a cyclic quadrilateral. So let's check that again. From theorem 5, it can also be stated that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. The exterior angle of a cyclic quadrilateral, that is a cyclic quadrilateral ABCD. and this S2 is the exterior angle. Now they now said that this exterior angle, which is S2, is equal to x1. So S2 equals to x1. How? Let us prove from this lettering given to us. X1 plus y, when you add the x1 plus y, that is equals to 180 degrees, opposite angle of cyclic quadrilateral. That's what we just concluded. When you add the opposite angle of a cyclic quadrilateral together, it must equals to 180 degrees. Then S2 plus xy will equals 180 degrees. That is sum of angles on a straight line. Now we now look at this. The S1 plus y equals 180. S2 plus y equals to 180 degrees. Both of them are equals to 180 degrees. Definitely this and this will be equal. S1 plus y will also equals to S2 plus y. Since this y are all together, they are the same. Let me collect like 10. Taking this y to the other side, S1 will equals to S2 plus y minus y. So y cancel y. Therefore, S1 equals to what? S2. From here, you can now say that, therefore, angle BCX, which is S2, equals to angle BAD, which is what? S1. So this is the opposite angle, but this one is the interior angle. So from here now, when you look at this cyclic quadrilateral, I can divide this into two. When I divide this cyclic quadrilateral into two, it forms two triangles. You know, this first triangle, total angles in this triangle equals 180 degrees. This one also equals 180 degrees. When you sum 180 plus 180, it's going to give us what? 360 degrees. This means that the total angle in a quadrilateral, ordinary quadrilateral, is equal to 360 degrees. So let us now move on to application of this theorem. Don't forget to subscribe to my channel if you haven't do that, and also share and comment on this lesson. So let's proceed. Example 1. In the figure below, line CE is a diameter. Line CE is a diameter of circle ABCDE. ABCDE. If angle ABC is equals to 127 degrees, find angle ACE. ACE, this angle here. Let us look at this angle very well. I want to find the angle that is there, which is angle ACE. Now, but we are told that line CE is a diameter. And don't forget that when we have a diameter, any angle formed by that diameter is going to be a right angle. That is 90 degrees. If I trace this angle this way, CED. So this angle D, the whole of this angle D here is going to be 90 degrees. It's going to be 90 degrees. That's the whole of that angle D. But when you look at this angle B and this particular angle here, this angle here, where I have arrow, when you sum them up, the angle is going to equal to 180 degrees, opposite angle of a cyclic quadrilateral. Okay, let me remove this 90. I'm still coming back to put it back. This angle here, let me call it angle A. So which means distance from here to this place where the arrow is, when you sum it up with 127, it will give you 180 degrees. 127 degrees plus A equals 180 degrees. Reason, opposite angles of a cyclic quadrilateral. That is, A will equals to 180 degrees minus 127 degrees. My A will equals to, that is 53 degrees. Now, I've gotten my A to 53 degrees. This place is 53 degrees. But since this is CE is my diameter, the total angle formed by this CE from here to here, this angle here, this one is 90 degrees. Okay? Now, I want to know this angle, this small angle here. If I can get this small angle, I will get this particular angle because they are angle in the same segment as we have proved before. So in this case, I can get this angle. Let me call it angle B. Angle B plus 53 degree is equals to the total angle there, which is what? 90 degree. So B equals to 90 degree minus 53 degree. B equals to, we have 7, we have 37 degree. So the angle B here is 37 degree. Definitely my angle ACE, angle ACE also equals to 37 degree. Reason, angle in the same segment. So in dealing with this circle geometry, we have to apply all the theorems that we have been using since the inception of this topic. So let's look at another example to buttress this theorem. Example 2. In the figure below, P, Q, R, S are points on a circle center O. Line QP is produced to X if angle SPS XPS is equal to 77 degree and angle PSO is equal to what? 68 degree. Find PQO. PQ. I want to find this angle. How can you proceed in this? We have to look at this very well and think of the theorem we have done. And think of other theorem we've learned so far. Okay, let me look at this. I have this angle here, which is 77 degree. I can do this way. This is exterior angle. And the interior opposite angle of this is this place. So I can get this angle here. Meaning my angle QRS is going to equal 77 degree. Exterior opposite angle 77 degree. I've gotten this one out to be 77 degree. Then I want to find this angle. Since this one is 77 degree, I can get this angle. If I add this and this together, it will equal to 180. Sum of angles and the opposite angle of cyclic quadrilateral. Let me call this place B. Angle B plus 77 degree is equal to 180 degree. B equals to 180 degree minus 77 degree. My angle B equals to, we have 3. That's 103 degree. I've gotten my B, 103 degree. Now, this is where I want to calculate angle PQO. I'm looking at it this way. This one angle, another angle here, this angle here, and this angle. They are quadrilaterals. 1, 2, 3, 4. 4 angles, quadrilateral. If I can get this one, get this one. If I can get this one, it will be easy for me to calculate this. Okay, since I've gotten this place to be 77, the center of this circumference is this point. And to get the center, it's going to be 2 times multiplied by 77. So the angle here, which is QOS, angle QOS, will be 2 multiplied by 77 degree. Reason is angular center is equals to 2 times angular circumference. So we are 154 degree. So the angle here now is 154 degree. Don't forget, we've gotten our B to be 103. Since we've gotten this one to be 103, sum everything up in this place, it's going to equal to 360 degree. That is angle PQO plus the angle here, 154 degree plus 68 degree plus the angle B that we got, 103 degree, then equals to what? 360 degree. Reason, sum of angle in a quadrilateral. Angle PQO plus 325 degree plus 360 degree. So angle PQO will now equal to 360 degree minus 325 degree. So angle PQO equals to, so what do we have? 35 degree. So our angle PQO equals to 35 degree. I believe you are flowing with me. Now, before we now proceed here, please try to share, like this lesson, and also leave a comment. Now let's proceed in example 3. In the figure below, calculate the value of x, giving a reason for each step in your answer. We are going to be given a reason. You know, the previous one we have been doing, there must be a reason for each step. Fine. Want to find the value of x here? We are given angle A, 2x degree. Part of this angle B is 60 degree. Angle E, s degree. How do we now find it? Okay. Okay, looking at this from the theorem we just concluded, this angle A can be equal to this exterior angle here. So I can get this angle here. So which means that, let me call this place small letter A. Small letter A is going to be equal to 2s degree. Reason, interior opposite angle of a cyclic quadrilateral. Interior opposite angles of a cyclic quadrilateral. So this place now is 2x. Now, looking at this angle BCE, they are angle in a triangle. So when I sum them up, 60 degree plus my A plus s degree equals to 180 degree. Reason, sum of angles in a triangle. So 60 degree plus my angle A, 2s degree plus s degree equals 180 degree. So 60 degree plus 2x degree plus x, we have 3s degree is equals 180 degree. Collect like terms. 3x degree equals 180 degree minus 60 degree. 3s degree equals to 120 degree. So divide both sides by 3. My x equals to 40 degree. So which means that the value of x here is 40 degree. So this is where we are going to stop at for this lesson, until we meet in the next lesson. And before then, if you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent lessons. And don't forget to share, like, and leave a comment as you leave this channel. You can lay your hands on the assignment comment shortly and send your surveys to the number on the screen. Thank you very much.